All right, so let's begin section 6.4. Section 6.4 talks about inverse trigonometric functions and right triangles. For a lot of this, at the beginning, you will have seen it before. Okay, so in this section, we're going to discuss the inverse sine, inverse cosine, and inverse tangent functions, which are also called arc sine, arc cosine, and arc tangent. We're going to solve for angles and right triangles, and we're going to evaluate expressions involving inverse trigonometric functions. Okay, so we're going to tie what we know about inverse functions to right triangles. Okay, now recall these functions. We've already talked about this in a previous section, so let's just do a quick recap. So again, the sine, cosine, and tangent functions on the restricted domains, respectively here, are one-to-one, and so they have inverses. The inverse functions have domain and range as follows. For sine inverse of x, the domain is negative 1 to 1, including negative 1 and 1. The range is negative pi halves to pi halves, including both of those. Cosine inverse of x, the range, the domain is negative 1 to 1, and that includes negative 1 and 1. The range is 0 to pi, including 0 on pi. Tangent inverse of x, the domain is all real numbers, and the range is negative pi halves to pi halves, that open interval. Okay, so with that in mind, there are a few examples that we're not going to go through in your book because we've already done examples like that. Okay, so we're just going to incorporate those functions with the new concepts we've learned about the right triangle. Okay, so let's go through example 1 here. Example 1. For example 1, we want to find the angle theta in degrees rounded to 1 decimal place. Okay, here we have a right triangle. We want to find out what theta is. What can we use? What do we know here? Can't hear you? Will the Pythagorean theorem help us find theta? No, it won't help us find theta. Think about your trigonometric functions. What do you know? What trigonometric function pops in mind when you see what I've given you here? Tangent. Good. Why?
Because you know both the legs, and theta, tangent of theta would be 7 over 18.
Very good. Tangent of theta, that's really large. Tangent of theta is equal to 7 over 18. Very good. Because tangent of theta is opposite over adjacent. Okay? Now we use our information that we know about inverse tangent, apply that to both sides. Now this step that I'm about to write, you typically do not have to write this step, okay? I'm just going to write it so you can see what's going to happen. But again, this step you do not have to write. Tangent inverse of tangent of theta would then be tangent inverse of 7 over 18. Now, tangent inverse of tangent of theta is just what? It's not tangent. You're composing tangent inverse and tangent of theta. So you just get what? Theta. Very good. You just get theta. So this left-hand side means theta. And then we have theta is equal to tangent inverse of 7 over 18. Now you enter that into your calculators, and what is that approximately? To the nearest tenth, because it said round to 1 decimal place. So we get this is 21.3 degrees. Okay. Now let's look at another example. Example 2. A 20-foot ladder is leaning against the building. These concepts are very important. You'll see these ideas again. A 20-foot ladder is leaning against a building. if the base of the ladder is 6 feet from the base of the building, what is the angle of elevation of the ladder? How high does the ladder reach on the building? So what should we do first? What would help us here? Drawing it out, right? So you have a ladder leaning against the building. So this was our ladder. What do we know about the ladder?
It's 20 feet.
It's 20 feet, good. So this is 20 feet. And we know that the base of the ladder, which is right here, is how many feet from the base of the building? 6 feet, good. So this is 6 feet. What is the angle of elevation? So this is what we want to find. We want to find theta. And what else do we want to find? The height of what?
The ladder.
How high does the ladder reach on the building? So are we looking for this, or what are we looking for? The building height here. So call that H. Call that H. So again, just to label what we've drawn out, let theta represent the angle of elevation of the ladder. Let H represent the height in feet that the ladder reaches on the building. Okay? So we've labeled our variables. Now, based on the information that we have in our right triangle, what trigonometric function do you think to use? Cosine, very good. Why? Because you have your adjacent and you have your hypotenuse. Excellent. So we can say then cosine of theta is equal to 6 over 20. 6 over 20 is 0.3. So we get cosine of theta equals 0.3, which means theta is equal to cosine inverse of 0.3. Are you with me? Yep, because it's using that similar step that I didn't write out, right? You apply cosine inverse to both sides. So you get theta's cosine inverse of 0.3, and what is that approximately? 72.5 degrees. Good. 72.5 degrees. Now, are we done here? No, because we have to find what? The height, or H. Very good. That's what we have to find. How can we go about finding H? You got it. Use the Pythagorean theorem. Very good. So, by the Pythagorean theorem, we know that h squared plus 6 squared is equal to 20 squared. And you should, by good form, put these in parentheses, right? Because if you had a negative, you'd have to adjust accordingly. But we're good here. So h squared is equal to 20 squared minus 6 squared. Or in other words, h is equal to the square root of 400 minus 36, which gives us what? So because everything else up here is given to us as whole, about what?
19.
Good, 19 feet. So approximately 19 feet. Good. Okay? What questions do you have? Okay, so let's keep it moving. So now we just have lots of examples, right? Another example. Example 3. A 50-foot pole casts a shadow as shown in the figure. Okay, so here you are. This is what you have. Express the angle of elevation theta of the sun as a function of the length s of the shadow. B, find the angle theta of elevation of the sun when the shadow is 20 feet long. So part A is just asking us to write an expression for what this triangle is giving us. What comes to mind? Tangent. Very good. Tangent. So what would you write for part A?
Tangent of theta equals 50 over 20.
You got it. Very good. Tangent of theta equals 50. No, equals what? 50 over what?
Oh, 50. It's not 50 over 20?
Not for part A.
Over part A. Oh, 50 over S.
Yes, it would be 50 over S. Very good. 50 over S. Okay? So, that means theta is equal to what? Inverse tangent of 50 over S. Good. That's part A. That's part A. Now for part B. For part B, where we have to find the angle theta of elevation of the sun when the shadow is 20 feet long, what do we do here? Now's what you said originally. Now what do we do?
Plug in 20 for S.
Plug in 20 for S. So that would give us theta equals tangent inverse of 50 over 20, or 5/2. And what is that? Approximately to the nearest tenth.
68.2 degrees.
Good, 68.2 degrees. What questions do you have? Does this make sense, what we're doing?
Yeah.
Okay. All right, let's look at another one. And these, you've seen ideas like this before, but now what we're doing is we're tying that into, we're tying that with the information that we're learning about inverses, as far as applying it to both sides. Okay? Tangent of theta, or let's say what we need to do first. Find all angles theta between 0 degrees and 180 degrees, satisfying the equation. Round your answer to 1 decimal place. Round your answer to 1 decimal place. So for the first one, part A, we have tangent of theta equals -20. So that means that theta is equal to tangent inverse of what? -20, good. And what is that approximately? -87.1 degrees. Good. Now we need to find all angles theta between 0 degrees and 180 degrees, satisfying the equation. So what will we do here? No, we cannot use the Pythagorean theorem here.
Would you subtract 180 degrees from, or add 180 degrees to 87?
Which one, subtract or add?
Add.
Add, Very good. You would take 180 degrees and subtract 87.1 degrees from it. Very good. So you would have 180 minus 87.1. That gives you what? 92.9 degrees. That would be the only solution in the interval 0 to 180 degrees, or from 0 to 180. That's the only angle there. Okay? B. Oh, I'm sorry. You have a question. Go ahead.
For the so are you adding the 180 because it's negative?
Yes.
Okay.
Yes.
You want it in that range of 0 to 180?
That's right. That's your restriction. And because that's your restriction, you have to add, not subtract.
Okay.
Does that make sense? That's a good question. That's absolutely correct. What other questions do you have? Okay. Part B, you have sine of theta is equal to 4/5. What does that mean about theta?
Theta equals inverse in parentheses 4/5,
Of 4/5. That's how you say it. Of 4/5.
which equals 53.1.
Approximately 53.1 degrees. Good. Well, that we don't have to box it. That's one solution, right? We can go ahead and box that. That's one solution, okay? That's one solution. So we can say one solution is theta equals 53.1 degrees. And we can say that's one because that's between 0 and 180, right? What else can we do? Can you give me another one? Because our question says find all angles theta between 0 and 180. So can you give me another one? Yes.
180 minus 53.1.
You got it. Good. So another solution is 180 minus, and technically remember you should have degrees here, right? So 180 degrees minus 53.1. And what do you get that's equal to?
126.9.
126.9 degrees. Good. There are no others. Okay? All right. So far so good. Do you have any questions, or what questions do you have here? No questions? Okay, let's keep moving. So now, here comes a part. We've done problems like this before, remember? But now, what we're going to do is we worked with problems before where this was a familiar point, but now that it's different, it's not so familiar, we have to use the right triangle that we learned, right triangle ratios that we've learned here. So we want to find the exact value of the expression. Cosine of tangent inverse of 4/3. Okay? So remember, for tangent inverse of 4/3, we have an angle theta where the tangent is 4/3. Do you remember that? So to draw an angle theta, this is a right triangle, so that should be a straight, right? An angle theta whose tangent is 4/3. What does that mean with this triangle?
How'd you know it's a right triangle?
Because that's what we're talking about. We're tying all of this information to right triangle ratios that we've learned last class. Yes?
The opposite, length is gonna be 4 and the base length will be 3.
You got it. Good. Good. So that's what we know. So We have, this is 3, this is 4. What is our hypotenuse? 5. Do we need to write out how to get it? Or are you good?
No,
You're good.
Sorry?
Oh.
If you need to see it, let me know.
I thought that was a question. No, I'm good.
Yeah, I'm asking. I'm asking if you need to see it. Yes.
I didn't need to see it, but, or did not need to see it, but isn't that a 3, 4, 5 triangle? that
Yes.
follows, like some special rule?
It is.
Okay.
Yes. Yes. But you can also use the Pythagorean theorem to get it.
Okay.
Either way. Yes. What other questions do you have right now? Okay, we're not done with this problem though. So we filled in our right triangle. So what we did was we drew, so I'm just writing out what we did. We drew a right triangle with angle theta, opposite side 4, and you technically you don't have to write this out every time. I'm just writing it down whenever you refer back to your notes. Opposite side 4 and adjacent side 3. Then from the triangle we have, or we see, that cosine of tangent inverse of 4/3 is the same thing as cosine of theta. Are we okay so far?
Yeah.
And what's cosine of theta?
3/5.
3/5. That's it. That's it. So just to explain how we started out, we said let theta be equal to tangent inverse of 4/3. Then we apply tangent to both sides and we get tangent of theta equals 4/3. That's how we were able to go here and label this right triangle and figure out this was a 5 here. And that's how we got here to say cosine of tangent inverse of 4/3 is cosine of theta, and that's 3/5. Questions? Okay, let's look at another example. Let's look at another example. And make sure you're working on math in this class. That's the last warning with that. I've been saying that a lot the past few days. Here we have cosecant of cosine inverse of 7/25. Would you like a minute to try it? See how it's nodding yes? Go for it. All right. So where did you start here? Yes?
You drew a right triangle and then.
You drew it right. Well, let me take it off the laser. Why am I switching this? I have no idea why I'm using a different color. You start out with your right triangle. There you go. Now what?
And then cosine is.
Where's your theta? Is it in the bottom left, top?
Bottom left.
Bottom left, theta.
And then it says cosine is adjacent over hypotenuse.
Mm-hmm.
I labeled the adjacent as 7 and the hypotenuse 25.
Very good. Very good. And you said that's true because cosine of theta would then be adjacent over hypotenuse, so you get 7 and 25 there. And then what'd you do from here?
I might have gotten a little confused, but then.
You want help?
I might have it, I'm not sure.
Okay, go.
Since cosecant is, cosecant's hypotenuse over opposite, I had to find opposite, which using Pythagorean theorem is 24.
That's correct. So here, that's your unknown. Your unknown is b. And so you use the Pythagorean theorem. So we have 7 squared plus b squared is equal to 25 squared. So that means b squared is 25 squared minus 7 squared. or B is the square root of 576, which you got to be 24. So we found out that was 24, as you said. And then what'd you do from here?
And then I got stuck.
Okay, who wants to help from there? Go ahead.
I just followed the steps from last one. I'm not really sure like how to actually do it, but next I did cosecant of theta, which is just inverse sine, so I got 25 over 24.
Is it inverse sine or 1 over sine? Ah, they're different. Good. So it's cosecant of theta is 1 over sine of theta, and that's equal to what?
25 over 24.
You got it. It's 25 over 24. Good, both of you. Good. That's it. What questions do you have? Okay, so now what we're going to do is we're going to take those ideas that we've learned, and now we're going to put it with something a little bit more abstract. But it all boils down to making sure that you really understand what it means for you to have those trigonometric ratios and applying them with the right triangle. Okay? So, in example 6, we want to rewrite the expression as an algebraic expression in x. So we're given sine of tangent inverse of x, and we want to come up with some mathematical or algebraic expression for that. So what we have to do, or what we want to do, we want to find sine of tangent inverse of x. Okay? So we're going to do like we've been doing. We're going to let theta be. So let theta be equal to tangent inverse of x. Apply tangent to both sides, then what do you get? Then what? Would theta be equal x? No. Theta is tangent inverse x.
You divide by x?
No, divide x is on the inside of tangent inverse. You can't do that. That's illegal math. You can't do that. You have your hand raised?
No, it's just stretching.
Okay. Remember that step that I said we don't always have to write in? Well, you're starting out with tangent inverse of x, so what should you apply to both sides? Tangent, right? Apply tangent to both sides. What do you get? Tangent theta equals x. Very good. Tangent theta equals x. Very good. Now, x is the same thing as x over what? 1. Good. So you have tangent theta is equal to x over 1. So remember, you can go to your right triangle. You have theta. And how do we label it here?
X is the height.
X is the height or your opposite. Mm-hmm.
1's the base.
1 is your base. Good. And now, to find the hypotenuse, what do you do? Use the Pythagorean theorem. See, it's the same idea. You're just dealing with things that are not necessarily numbers all the time. Okay? You're dealing with variables now. Okay? So, now using the Pythagorean theorem, the hypotenuse is what? What do you get for it? Do you wanna write out the steps?
Yes, please.
Yes, please.
What do you label the unknown? What did you label it?
With Whiteboard.
Y works. You wanna find y. So you have y squared would be equal to x squared plus 1 squared, or y is what?
X plus 1.
The
No.
y technically is c.
The variable doesn't matter. Yes?
X equals 2.
No. Yes?
X squared equals 2.
Y equals square root of quantity x squared plus 1.
The square root of what?
Quantity x squared plus 1.
Not the quantity x squared plus 1.
It's just x squared plus 1.
X squared plus 1. All of you said something different. Okay? And let me tell you why the only one that's correct is the one I wrote down. Okay? So I'm going to move this up and over, use a different color. I heard some people say that it was going to be x plus 1. And then I heard the quantity x, was it x plus 1 squared? What was the other one? There was one more. Well, let me point out why neither one of these is true. The square root of x squared plus 1 squared does not equal the square root of x squared plus the square root of 1 squared. That's not true. You can only break apart a radical of something that you're multiplying. Okay? So that first one would not work there. Also, remember that x plus 1 squared is equal to x plus 1 times x plus 1. And that's x squared plus 2x plus 1, which is different than what we have. Okay? So make sure you leave these alone and take the square root of them. Does that make sense? Yes? No?
Yeah.
Okay? So we get y. All of that to say we found our hypotenuse. We got y was equal to the square root of x squared plus 1. Now we're in good shape because we have sine of tangent inverse of x is the same thing as sine of theta. And sine of theta is what?
X over square root of x squared plus 1.
You got it, and you leave it just like that. That's sine of theta. That's sine of tangent inverse of x. So we wrote an algebraic expression in x. What questions do you have? That's section 6.4. That's section 6.4. The inverse trigonometric functions and right triangles. So make sure you work through your homework from this section.